Welcome to Muromax. Today let us discuss a problem from the unit multiple integrals. So the question is, transform the integral into polar coordinates and hence evaluate integral 0 to a, integral 0 to root of a square minus x square, integral function is root of x square plus y square dy dx. So writing the given integral function as some I, let I is equal to integral 0 to a, integral 0 to root of a square minus x square. Integral function is root of x square plus y square dy dx. Here the limit is given in terms of x. Here the limit varies from 0 to root of a square minus x square. Here the limit is given in variable, that too it is given in x variable, which means that this is the limit of y. Which means that this is the limit of y and this is the limit of x. So dy dx. So question is to transform the integral into polar coordinates and then we should evaluate the value of this integral, which means that here it is given in Cartesian coordinate. Here completely the limit as well as the integral function, everything is given in Cartesian. So we have to convert this Cartesian into polar. All the limits as well as the integral function, everything completely we have to convert in polar and then we have to evaluate. That is the question here. Right. So first of all, finding the region of integration first. Region of integration. Region of integration. Writing down the limits, writing those limits and from that finding the region of integration. Here x varies from 0 to a. X is equal to 0 to x is equal to a. And y varies from 0 to root of a square minus x square. That is, y varies from 0 to y is equal to root of a square minus x square. So rewriting this alone as, so this becomes, when we square both sides, it becomes y square is equal to a square minus x square. Again we can rewrite this as x square plus y square is equal to a square, which is nothing but a circle. So x square plus y square is equal to a square, y is equal to 0, x is equal to 0, x is equal to a. So marking all this in graph. So here x square plus y square is equal to a square is nothing but a circle with center as 0, 0 origin and radius as a. So this is origin, let this be x and this be y axis. Here let it be, here this be a, x is equal to a. So circle has to be somewhat like this. Circle somewhat like this. So the center is 0, 0 here. X square plus y square is equal to a square, which means the center is the origin 0, 0 and radius is a. So which means the circle becomes this way. Right. Now the region, overall region is bounded by, that is from x is equal to 0 to x is equal to a. We know that x is equal to 0 is nothing but y axis. Y axis. So y axis, here it is x is equal to 0. It is x is equal to 0. X is equal to a. So x is equal to a is a straight line at the point x is equal to a parallel to y axis. So at the point x is equal to a, we have to draw a straight line parallel to y axis. So this becomes x is equal to a. So this line is x is equal to a. So x is equal to 0 is over y-axis, x is equal to a is also over, x square plus y square is equal to a square, circle is also over. So the equation of this circle is x square plus y square is equal to a square. This is also over. Then y is equal to 0. Y is equal to 0 is nothing but x-axis. X-axis, y is equal to 0. Now the region is bounded by, the region, overall region of integration is bounded by x is equal to 0 to x is equal to a. From x is equal to 0 to x is equal to a. From x is equal to 0 to x is equal to a. From here to here. From here to here. From here to here. From here to here. It goes on like this. From x is equal to 0 to x is equal to a. The line x is equal to a. It goes on like this. Again, from y is equal to 0 to this curve. From y is equal to 0 to this curve. Y is equal to 0 is this one. Y is equal to 0 is this line x-axis. So from here to the curve, the circle. From here to 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 the circle. It goes on like this. From here to the circle. From here to the circle. From y is equal to 0 to the circle. From y is equal to 0 to the circle. So region of integration is nothing but the intersecting region. Whichever region intersects, that region becomes the region of integration. So intersecting region is, so this becomes the intersecting region. So this region becomes the intersecting region. So this becomes the intersecting region. Right, this is over. Now considering the polar coordinates, because the question is to transform the integral into polar coordinates where everything is given in Cartesian. So Cartesian, whichever is given in Cartesian, we have to convert all the terms into polar and then we have to evaluate. So the transformation is given by, so transformation from Cartesian to polar. Transformation is given by x is equal to r cos theta always. X is equal to r cos theta, y is equal to r sin theta, and dx dy is given by r dr d theta. This is the transformation. Transformation from Cartesian to polar. Cartesian அப்படிங்கிறது xy ல வந்தா Cartesian, polar அப்படிங்கிறது r and theta ல வந்தா, that is said to be polar. So from Cartesian to polar, transformation is given by x is equal to r cos theta, y is equal to r sin theta, dx dy is equal to r dr d theta. Right. Now substituting all this in the limits as well as in the given integral function. Now substituting these substitutions in this curve gives us x square plus y square is equal to a square, which means that x takes the value r cos theta. So r square cos square theta plus y takes the value r sin theta. R square sin square theta is equal to a square, which means that r square is common. Inside it is cos square theta plus sin square theta is equal to a square, and cos square plus sin square is equal to 1. We know that cos square theta plus sin square theta is equal to 1. So finally we get r square is equal to a square, implies r is equal to plus or minus a. So r is equal to a. In this region it is r is equal to a. So the equation, so this equation of the circle is also equals to r is equal to a in polar form. So x square plus y square is equal to a square. This is the equation of this circle in Cartesian, whereas equation of this circle in polar is given by r is equal to a. So r is equal to a. We have converted it, the equation of circle, as polar. R is equal to a. Now Now considering a line from origin to the curve. Considering a line starting from origin to the curve. That becomes the limit of r. Because we have to convert all the terms in terms of r and theta. We have to convert Cartesian into polar form. Cartesian x comma y into polar form r and theta. So in the case of polar, we never consider strip parallel to x-axis, y-axis. That is not the procedure we follow in the case of polar. In the case of polar, to find the limit of r, we always consider a straight line from origin to the curve. So we have considered a straight line from origin to the curve. So limits. The initial point of the line segment r is equal to 0. Initial point of the line segment lies on the origin. So the initial value becomes r is equal to 0. The lower limit becomes r is equal to 0. So r is equal to 0 to the curve. The curve in polar form is r is equal to a. So r is equal to 0 to r is equal to a. So equation of this curve, this circle in polar form is r is equal to a. We have converted it here. We have converted the equation of the circle in polar form, which is r is equal to a. So from r is equal to 0 to r is equal to a, because our question is to transform the complete integral into polar. Everything, all the limits as well as the integral function, everything should be in polar form r and theta. So we have converted this circle, equation of circle into polar form, which is r is equal to a. So limit of r is over. Next we need limit of theta. When we check, theta varies from here to here. Overall complete first quadrant. So intersecting region, our area to integrate is the complete first quadrant from here to here, which means that theta varies from 0 to pi by 2. Theta is equal to pi by 2. Now we should convert the integral function into polar. Integral function root of x square plus y square into polar implies root of x square plus y square is equal to root of transformation, conversion is x is equal to r cos theta. So r square cos square theta plus here we have y square. Y is given by r sin theta. So we get r square sin square theta. And we know that cos square plus sin square is equal to 1. So square root of, taking out r square is common, inside we get cos square theta plus sin square theta, which becomes 1. So finally root of r square, which is equal to r, that is root of x square plus y square. Root of x square plus y square is equal to r. Integral function is also over. Now substituting it in I. Let this be equation number 1. So equation number 1 becomes I is equal to double integral. Integral function is r. We have dy dx there, and dy dx transformation is r dr d theta. So r dr d theta, and limit of r is 0 to a and limit of theta is 0 to pi by 2, which is equal to integral 0 to pi by 2 integral 0 to a. This is r square dr d theta, which is equal to integral 0 to pi by 2 r square. Integration of r square is r cube by 3. Integral r cube by 3. Integration of r square is r cube by 3. Now limits 0 to a, left out d theta. Because we know that integration of x power n dx is given by x power n plus 1 by n plus 1, which is equal to 1 by 3 integral 0 to pi by 2. I have taken this constant 1 by 3 outside. So 1 by 3 integral 0 to pi by 2 r cube, just r cube, upper limit minus of lower limit. We should raise the limits. We should raise limit for r. We have to substitute r is equal to a here. So upper limit is a. So it becomes a cube lower limit is 0. Even if we substitute 0, it becomes 0. Overall, the term becomes 0. So, omitting that. A cube, left out d theta, which is equal to, again taking this constant a cube outside. So, we get a cube by 3, 0 to pi by 2, just d theta alone, which is equal to a cube by 3. D theta, integration of d theta, we get theta. Theta, limit 0 to pi by 2, which is equal to a cube by 3, upper limit minus of lower limit, which is pi by 2. Lower limit 0, even if we substitute, it becomes 0. Overall term becomes 0. So, omitting that. So, finally, I is equal to pi a cube by 6. This is the required value of the integral function. Thank you guys.